life. 10 million fireflies lit up the world as I fell asleep.
Light has been around forever, such as light from one of our greatest natural resources, the sun, as well as fireflies, glowworms, and the stars that light up the night sky. One of the earliest forms of indoor lighting stemmed from burning oil lamps and candles, which were the predominant solution to darkness until the discovery of truly artificial lighting that was generated from heating up a piece of metal.
This is known as the Davy lamp. It is a safety lamp with a wick and oil vessel burning originally using heavy vegetable oil. It was created for use in coal mines, allowing deep seams to be mined despite the presence of methane and other flammable gases. Davy had discovered that a flame enclosed inside a mesh of a certain fineness cannot ignite fire damp. The screen acts as a flame arrestor. Air can pass through the mesh freely enough to support combustion, but the holes are too fine to allow a flame to propagate through them and ignite any fire damp outside the mesh. British-born Warren de la Rue passed an electric current through a coiled platinum filament in a vacuum tube. The high operational melting point of platinum and the evacuated chamber would contain fewer gas molecules to react with the platinum, improving its durability. However, the high cost of platinum made it impractical for commercial use. Joseph Wilson Swan began working on a light bulb using carbonized paper filaments in an evacuated glass bulb. By 1860, he was able to demonstrate a working device and obtain a British patent covering a carbon filament lamp. However, the lack of a good vacuum and an adequate electric source resulted in an inefficient bulb with a short lifetime. 15 years later, Swan returned to consider the problem of the light bulb with the aid of a better vacuum and a carbonized thread as a filament. The most significant feature of Swan's improved lamp was that there was little residual oxygen in the vacuum tube to ignite the filament, thus allowing the filament to grow almost white-hot without catching fire. After many experiments with platinum and other metal filaments, Thomas Edison returned to a carbon filament. The first successful test was on October 22, 1879, which lasted 40 hours. Edison continued to improve this design, and by November 4th in the same year, he filed for a US patent for an electric lamp.
Organic light-emitting diode, or LED, is an ultra-thin light source made out of flexible plastic, which contains two electrodes. The electrodes are transparent and coated with wafer-thin layers of organic material that generate light. The electrodes are then encapsulated in order to protect the organic layers from damage. Essentially, OLEDs consist of three layers: a transparent anode, a middle layer of light-emitting organic materials, and a colorless metallic cathode. When connected to a source of power, electrons flow from the negatively charged cathode in the direction of the positively charged anode. Light occurs at the point where negatively and positively charged particles collide within the middle organic layer, without any indirect loss of energy. This process repeats itself an infinite number of times per second across the whole surface of the OLED. The result is an evenly distributed shadow-free light.
Till now, free configuration of lighting applications has been severely limited by installation depth or high heat generation. We believe our flexible, transparent OLEDs are the solution. They can be easily integrated into a wide range of products, and lighting problems belong to the past. The OLED lights provide a creative interior lighting solution that can be adapted to suit the different functions throughout the home. The possibilities with OLEDs are endless, as they are extremely environmentally friendly and can be tuned to any imaginable colour at a wide range of light intensities. One of the most fascinating applications for our flexible, transparent OLEDs is the installation of our lights in the form of windows. The OLEDs used in this case are invisible during the day and would be able to give the room a daylight feeling after dusk. As they are very energy efficient, they could easily be used in the kitchen, as lights tend to be kept turned on for extended periods of time. In bathrooms, they can be used safely too, even when there is steam. They can even be used in cars as roof interior lighting. Light intensity can be at any time adjusted to suit the ambient conditions. They can also help in finding one's way around the car dashboard, or in highlighting brand names in any imaginable colour. We believe that OLED are the stepping stone to intelligent lighting solutions of the future.
First point is the fact that OLEDs are flexible, so you can put them, for example, on flat surfaces, curved surfaces, pretty much any surface really, so that's one advantage. Next advantage is the fact that they are dimmed easily, so you can get dim lighting through the switch. That still applies with OLEDs as well, so you won't use that sort of technology as well. And also colour. With most light bulbs today, you need a certain light bulb for a certain colour, i.e. white light bulb for a white light, red light bulb for a red light. With OLEDs, for example, the way they are composed, you can, in theory, get different colours from a sheet of one OLED. You should just stop thinking about just replacing the light bulb. OLEDs can be used for clothing, for example. So where for cyclists wear high visibility jackets, we can replace them with just normal jackets that have OLED incorporated into them, so that when they are in the night they can literally be as bright as a high visibility jacket without the fashion factor being involved, for example. Another application could be in curtains. So if a person doesn't want to draw the curtains open, for example, to let the light in, OLEDs can be used in the curtain fabric to incorporate light into that. The main advantage of OLEDs is they are very environmentally friendly. They're all based on organic products, so there's no use of any harmful chemicals in the actual making of the OLED. Manufacturing OLEDs is actually not that particularly expensive when you use certain technologies, for example. So, for example, OLEDs can be manufactured using the print technology, which is the same technology used to make newspapers. There are also LEDs. So LEDs are light-emitting diodes, but the only problem with them is they are a point source, whereas OLEDs are a diffuse source. For example, an LED would be light up a certain point, whereas an OLED could light up the whole board.
Yeah?
Yes. I think it's good.
They're good. I do think it's a good idea.
I think it's a good idea.
Sounds like a nice idea.
Yeah, it sounds good.
Probably not, because I'm very old-fashioned.
If you sold it for a decent price?
Yeah, if it wasn't expensive, then I probably would.
Possibly, depends how much it would be.
Probably.
Yes, I could well use it.
Yeah.
Of those energy-saving light bulbs.
Yeah, definitely.
Probably not as conscious as I should be.
Yes.
Yes.
Yeah, it's good to save the planet.